0. Okay. So implicit differentiation, quite an easy skill, but just looks horrible. And this is when you have x and y terms in the function. Okay. So what we have here is this is a function of x. This is a function of y. And then this is a function of x and y. Okay. So what we have to do is this question, for example, to find the maximum or minimum values, we'd want to know, like this is, if we were trying to find here, a tangent here or here, this is where the gradient is 0. So we are looking for dy dx. The problem is it's a horrible thing to sort of differentiate. So we know dy dx would equal to 0 in these places. Not drawn that one very well. It's because I'm a bit scared of that side of the screen. So that's what we're looking for. Now, to differentiate this implicitly, let's have a little look. What we do is the x terms and the constant terms, we can just do as normal. So we know that that bit is 2x, and we know that that bit is 0. Okay, so that's the first thing we can do. The tricky bits are the bits that involve y. Okay, because we're differentiating with respect to x fully, but we've got some y terms to deal with. So going back through this, implicit differentiation is effectively like a chain rule on y. So what this tells us is that if we're differentiating with respect to x, a function of y, so let's say some function, and we'll run a couple of minutes after one, guys, but we'll take a sort of 15-minute break. So I don't want to rush important content. So this will become dy dx times f dash of y. Okay, so differentiating the outermost thing with respect to what's in it would be f dash of the thing, but then you got times by dy dx, because that's the derivative of y with respect to x. So if you ever differentiate a y term, you actually get a dy dx. So that's where this starts looking complicated. So this derivative here, 2y squared, is actually a chain, because what we can think of is the function of y is 2y squared, and y differentiated is a dy dx. So differentiating the big picture, you'd get a dy, you'd get 4y, but you've got a times by the innermost function derivative, which is a dy dx. So you actually get 4y dy dx. So this one's quite nasty because it's actually a product. So let's have a little look. So here for this term, you're actually doing like a d dx of a function of y. I'm sorry, I'm rushing this a bit. Calm down. Function of x times a function of y. Okay. And remember that that will become derivative of that plus the other way around. Okay. Now, if we do that for this one, the derivative of 2x with respect to x is 2. And you'll have a 2x over here. And then we're not going to differentiate y. Plus 2x not differentiated times the derivative of y would be a dy dx. So that would be the derivative of this. It's a product rule. Okay, so we're going to put this all together and see how we go. Here we go. So differentiating each of these bits, that becomes 2x. That became 2y plus 2x dy dx. This one, remember, became 4y dy dx. And this one became 0. So if we rearrange it all to one side, get the dy dx's on one side and the other bits on the other side. And then we can divide and sort of simplify that, cancel that down. We'll get the following derivative as minus 2x minus 2y over 2x minus 4y. And we want to solve where it's equal to 0. Now, this is a really good question because we were asked for like the turning points. Now, if you're asked where a fraction is equal to 0, you actually don't need to panic too much. You're just solving the numerator equals to 0. That's all that means. So basically, we're solving when is minus 2x minus 2y equal to 0. Well, when minus 2y equals 2x. So when y equals minus x. So we know that these like lie on the line y equals minus x, where those stationary points are. So what we can do is like simultaneously solve that now, put that back into there, and let's do that. So what we would have is x squared plus 2x times minus x, so minus 2x squared, and we're replacing y with minus x. So that would actually become plus 2x squared because it's minus x all squared equals 4. You get a quadratic x squared minus 4 is 0. So x equals 2 or minus 2. And you can sub that back in to that line to find y equals 2 or minus 2. And then you found the coordinates, sorry, on there of the stationary points. So minus 2, 2, and 2 minus 2. Okay, so that was a good one to look at. So what we're going to do, we are going to take a quick break. Apologies, that was quite quick, that bit. But what I'll do is I'll leave you with this one to think about, and then I'll put the answers up in a minute. We'll reconvene just after 1:15. And then we've got our session on integration, and I'll put the answers up. As I said, you will get sent all these answers when you fill out the survey, but give yourself a quick break and I'll speak to you about 1:15. Okay, cool. Right, guys, we'll be back in like 3 minutes. And then we'll move on to integration. Well done. Make sure you've had a bit of a breather and speak to you shortly. Right, okay. Guys, I'll put the answers up for this one, and then we are going to start integration, which is going to be quite a full-on session before statistics on hypothesis testing. So the answers to this one, if you did want to make a note or if you have done it, implicitly differentiating this, x squared and 1 as normal. The y will become a dy dx. It's the x cubed y squared that's an annoying product rule question that you'll have to do. So that's the bit we need to pay attention to, that x cubed y squared part. And so what we will end up having is that will become 3x squared y squared plus 2x cubed y dy dx. That's the bit you probably want to take the time over, double check, and just make a note of. Like I said, you'll be sent all the solutions for like the mini mocks and everything once you fill out the sort of survey stuff at the end. But putting it all together, that's what we get. So we get the 2x, the minus dy dx, that product rule. The other bit went to 0. So then it's just collecting like terms, get the dy dx's on one side, get all the other stuff on the other, and then divide through to just leave dy dx on its own. So that was the final answer if you want to write that down. They did also ask the gradient at the point -1, 1. So you have to then sub that in and find it as a number, which ended up as 5/3. Well done if you got that.